So with that, I'm going to turn it over to Precom Joshi, my co-founder and CTO, to go over some amazing work that he's done on RAG relevance and LLM output quality. There you go, Precom.
Great, thanks. Well, hope everyone can hear me. So that's the QR code if somebody wants to take a picture. But even if you don't, that's totally fine because I have the link right here. So I promise that the challenge that we will have for this is going to be super simple. It's a Colab notebook. You can literally download it, clone it, and then run it, right? So I'm going to be showing you how to improve your LLM applications by at least 30%, and also the retrieval quality by over 100%, right? And you'll be wondering how is that possible? So we'll go through that in a little bit. But before we get into this, how many of you have built an LLM applications or are building an LLM application? Raise a hand. Okay. Great. Awesome. So this should be pretty relevant to you. Okay. So in terms of what we're going to cover in this, we will build an LLM application that answers the user query related to a MeetingBank dataset. So the MeetingBank dataset is essentially a transcript of a meeting notes from 6 major councils and city councils essentially. So we'll use Weaviate for our vector database. We'll also use LlamaIndex here just to make things a little bit easier in terms of writing shorter code, right? And then we'll judge the output quality using AIMon's judges that Puneet talked about. So yeah, so if you go ahead and run through this notebook, so the only thing that we need to do here is sign up for an AIMon account and then add the AIMon API key right here in this note in the Google Colab secrets. It should take you about 20 seconds to do that once you get started. So the next step after that is just download this file, which is an encrypted file. We have some keys which we have a temporary password for you for, which has been pasted here. It will be invalid after maybe a day or so. And these keys essentially will allow you to decrypt this file, which will then go ahead and populate all sorts of keys that are needed to run this notebook. So let's do that and there and then yes. So that's that. So we'll go through that. There are some utility functions. You don't need to worry about them. Ignore them, right? In terms of the dataset, the MeetingBank dataset is actually quite large. We have curated a smaller portion of it for you, and that one can be again found here. So we'll download this dataset. I'm going to show you how many items it has. This one just has about 258 items there, and then you can see the total number of tokens there is about 996K, about 1 million tokens or so. And then you have the transcript split, and this is a quick overview of how a transcript actually looks like. You can see that it's a transcript from a council meeting, right? And then this one just shows you like the average number of tokens per transcript that you have. It's about 3,800. So this is the overview of the data set. For queries, again, popularly, I've curated a set of queries. I've used LLMs to generate these queries. Also manually tuned them to make it a little bit hard for your LLM so that you can actually see the improvement of your application over time, right? So, okay, all of that is well and good. The most important thing over here to pay attention to is this metric definition, right? So we will define what we call as a quality metric. Now the quality metric is a combination of 3 different metrics here. One is the hallucination score, the second is the instruction adherence score, and the third is the retrieval relevance score. So you can see that I've created a weighted sum of all of these scores. So hallucination score essentially checks whether the generated text is grounded in the provided context. Instruction adherence essentially checks if all of the instructions of your LLM that you wanted to follow have been followed, right? Now here is where you can define how you want your LLM or application to behave. So in this case it would be something like, make sure that it answers all parts of the query, it's under 50 words, it has a friendly tone, it does not have any abusive language, and so on and so forth. So and again, you can just paste your prompt because your prompt essentially has all of these instructions, right? but for the sake of clarity, I wanted to show you this in an enumerated format. Yeah, so essentially go ahead and execute that, and then this one. For the first approach, yeah, so before we do that, we'll be using AIMon to do the evaluation to basically compute this relevance metric, or sorry, the quality metric that we have generated here, right? So this is what we call the detect decorator. So once the decorator has been set up, we will go through a step-by-step approach. So the first approach we will take is you will simply use Levenshtein distance to match a document to a query, brute force, right? And then we will take like the top 3 documents and then send it to an LLM to answer the question. That's it. So if you go through that, I won't execute this because this brute force approach takes about 168 seconds because it's quite slow, right? But essentially what happens is AIMon looks at the output of your LLM and then it grades, gives you a relevance score for the output. So you can see the overall quality score here is about 55, so that's our baseline, right? And this is the average retrieval relevance score. So the stuff that you got from the top 3 Levenshtein distance match, that's at about 14%, right? So that's your baseline. So now we'll add in Weaviate, and for this exercise we have already pre-baked a serverless Weaviate instance for you with this data set, so you don't have to do that, don't have to compute the embeddings and whatnot. So we'll go ahead and yeah, but if you want to do that, if you want to change how the embeddings are computed, we have some code there to help you do that. But over here, this is the index name, and then yeah, we're going to be setting up an LLM. The LLM of choice here is just your OpenAI, which we will be using. After that, we have a simple ask and validate function, which is what you would need to do to integrate with AIMon. This little function here again is just to help with LlamaIndex, to interface with LlamaIndex, right? So we go through that and then run through ask and validate. This one is just to see if you issue a query, is everything working fine. So what you would see is something like this. This is quite verbose response from the API, right? And then finally go through the same exercise. So basically call Weaviate, for each query get a set of documents or chunks that are relevant to your query, and then call your LLM with those chunks, right? So after you go ahead and do that, you can see that the overall relevance score improved by a little bit, right? Like about 3% or so. So that's the first step. And the retrieval relevance score also improved because of the way we have computed the embeddings and whatnot. So yeah, so we'll go ahead and do that. And the last step, people mentioned about reranking here. I want to share what reranking actually does, right? So this little diagram is pretty helpful. So when you query your vector database, you get a set of documents back. So if you have 1 million items in your vector database and you get maybe 25 or maybe 100 items back, this is typically how it looks like. The most relevant items might still be, say, at the first position, at the 50th position, and at the 100th position. So what the reranker essentially does is bubbles up those relevant documents for your query right at the top, right? So that's basically what it's doing. And we have a reranker which, like Puneet mentioned, we essentially help you ICL your reranker for your domain. So it's domain-adaptable reranking. And that is possible using the task definition field, which again you can play with. Like in this case, your task is to match documents for a specific query. The documents are meeting transcripts of 6 major cities, right? So you give it some examples. So this is a quite simple task definition. You can give it even more details. You can give it like few short examples and whatnot. And again, our reranker ranks in the top 5 in the MTEB as of now. So yeah, so go ahead and do that, and then again this should take about 2 minutes. You can see from the previous one, if you remember what the previous relevance scores were, this is quite much higher, right? So and then the overall relevance score here is about 69%. So going through all of this, we have a table here which shows all of the improvements. So the brute force obviously is the baseline. We had about a 2.3% improvement when we added the vector DB. When we added AIMon, we got about 25%. And just to show you, your mileage will vary depending on the LLM's response, right? So you can actually get up to 30%. The cool thing here is we got almost 144% improvement in your relevance, retrieval relevance score by using this approach, right? So again, what we did here was we evaluated, we took a structured approach to evaluating the quality of your LLM application, and we improved it using the information that we got out from AIMon. Right? Yeah, so that's how the challenge works. Give it a shot. We would love to hear some feedback. Here, there are some suggestions at the very end, that talk about possible things that you could do. Yeah, you could basically modify the instructions field to your own custom definition, and then you can add, other AIMon checker models, which is linked here. Yeah, so that's it from me.